This is section 9.3 of accelerated geometry, arcs and angles. First of all, we have to have a definition. A cyclic quadrilateral is a quadrilateral, a four-sided figure inscribed in a circle. Each angle is inscribed in the circle, and each side is a chord of the circle. So this here is a chord. This is a chord. A chord is a segment inside a circle with its endpoints on the circle. So those are four chords. And then I have four inscribed angles. There's one. Here's two. An inscribed angle, remember, has its vertex on the circle. And here is another. So we have each inscribed angle. Each angle is inscribed in the circle. Each side is a chord of the circle. Each of the vertex points is also on the circle. A secant is a line that intersects a circle in 2 points. Remember, a tangent is a line that touches the circle in 1 point. A secant touches it in 2 points, here and here, for example. It contains a chord. So between those two endpoints is actually a chord. And it passes through the interior of the circle, through it. So it's not inside, it goes through it. Now, there are many investigations that lead to many conjectures today. So if we were in class, we would be doing these conjectures. But we're not. So I'm going to go over here and run through the conjectures. So the first conjecture of section 9.3 is conjecture number 81. And this is what it says. An inscribed angle equals half the measure of its intersected arc. Okay, now let's go through this. An inscribed angle, remember, is an angle inside the triangle, which has its vertex on the circle. So this is an inscribed angle. An inscribed angle equals half the measure of its intercepted arc. So this inscribed angle cuts off this arc right here. That arc is 102 degrees. And this angle is 51 degrees. So an inscribed angle is half of its intercepted arc. So if this is 102, this angle would be 51. If I have another inscribed angle, and this is 40 degrees, then this would be 20. If I have another inscribed angle, and I know that this is 60 degrees, then this would be 120 degrees. So that is conjecture number 81. 82 says, inscribed angles that intercept the same arc are what? So let's think about it before we give you the answer. Inscribed angles that intercept the same arc. So let's say that this is the arc here, from here to here. Inscribed angles that intercept the same arc. So there's one inscribed angle, and here is another inscribed angle. Well, from the last conjecture, if this is 60 degrees, an inscribed angle would be half of that, and if this is 60 degrees, this inscribed angle would be half of it. So it seems that inscribed angles that intercept the same arc are equal. So here's this arc, and angle C would be equal to angle D. Angles inscribed in a semicircle are what? So here's a circle. Here's the center. That's the diameter. And that creates a semicircle. So this is a semicircle. Half of a circle. That's 180 degrees. If I have an inscribed angle on that semicircle, if this arc is 180 degrees, the inscribed angle is half of that, so it would be 90 degrees. So they are right angles. Okay, conjecture number 84. Opposite angles in a cyclic quadrilateral are what? They are supplementary. So it says in the drawing here, this is a cyclic quadrilateral. All the vertex points are on the circle, and all the sides and the angles are inside. And they say in here that these add up to be 180. A plus C adds up to 180. D plus B adds up to be 180. Now, why is that? Let's just draw a line that goes from here to here. Okay, this is half of this, and this inscribed angle is half of this. So together they are half of a whole 360-degree circle. So half of 360 degrees would be 180, which means that they are supplementary. And the last one, parallel lines intercept something on a circle, congruent arcs. So here are two parallel lines, right here, parallel and parallel, and they cut off these two arcs, and those two arcs are always going to be equal. So that is the lesson for this section on arcs and angles, section 9.3.